Black holes, we know, are the most mysterious objects in the cosmos. Over the years, scientists learned many things about them, yet we barely understand 5% of what they are. Scientists recently found a black hole in deep space that is growing so fast our current models can't explain it. And that, trust me, that's much scary than how it sounds. You might think black holes are supposed to be monsters. Yes, but even monsters have limits. Most people imagine black holes like cosmic vacuum cleaners. Anything nearby gets pulled in, swallowed, and gone forever. But in reality, a feeding black hole is much more chaotic. The gas around it doesn't fall straight in. It spins around the black hole at terrifying speed, forming a blazing hot disk. That disk becomes so bright, so energetic, that it can outshine an entire galaxy. And that creates pressure which pushes back against the same gas that is trying to fall in. So if a black hole tries to feed too fast, its own energy should start blowing the food away. In simple words, a black hole can choke on its own meal if it tries to eat too fast. That's why scientists have a limit for how fast a black hole can grow. But recently, scientists found something which broke all the understands we have about them. They found one that seems to ignore all the laws of physics. It is called ID830. This black hole appears to be feeding at almost 13 times the expected limit. Not 13% faster, 13 times faster. So according to our current understanding, this black hole should have hit the brakes. But it didn't. And that's the real problem. Because ID830 existed in the early universe, a time when there should not have been enough cosmic history to build something this massive. So this discovery points to one big question. How did the universe create giant black holes so early? Were they born bigger? Did they grow through violent feeding bursts? Or are we missing an entire chapter in how black holes evolve? That's what we're going to explore. First of all, let's understand this. Black holes don't grow just because they are powerful. They grow only when matter actually reaches them. And that is not as easy as it sounds. As I said earlier, that gas around a black hole doesn't fall straight in like water going down a drain. It starts spinning around the black hole faster and faster, forming a blazing disk of superheated matter. This is what we know as accretion disk. And this disk is not peaceful. It is hot, violent, and insanely bright. In fact, when a supermassive black hole is actively feeding, the area around it can shine brighter than an entire galaxy. That's what we call a quasar. But you know what? That brightness is not just light, it is energy, and energy can push. So while the black hole's gravity is pulling gas inward, the radiation from the hot disk is pushing gas outward. And at some point, they balance each other. That balance is called the Eddington Limit. If the black hole feeds below this limit, everything works normally. But if it tries to eat too fast, the disk becomes so bright and energetic that it starts blowing the incoming gas away. Basically, the black hole begins fighting against its own food. This is why scientists thought black holes could not grow endlessly fast. But when we started to look into the early universe, we found black holes that are already massive. Millions, sometimes billions of times heavier than our sun. When these black holes were formed, the universe was still very young. There simply should not have been enough time for small black holes to slowly grow into giants, at least not by following the normal rules. And then the universe started giving scientists clues that didn't fit the story. Some black holes were found spinning insanely fast inside galaxies that looked surprisingly normal. No obvious disaster scene, no fresh signs of a violent merger, just ordinary-looking galaxies hiding something extreme at the center. And that was strange, because if a black hole becomes extreme mainly through massive galaxy collisions, the galaxy around it should usually carry the scars, stretched arms, disturbed gas, a messy shape, something that says, yes, something huge happened here. But sometimes the galaxy looked calm. One famous example is NGC 1365. At its center, sits a black hole millions of times heavier than our Sun, spinning close to the maximum speed physics allows. And spinning up a black hole like that is not easy. Think of a merry-go-round. If people keep pushing it from random directions, it won't spin smoothly. It will shake, lose rhythm, maybe even slow down. But if the push keeps coming from one direction, again and again, the spin becomes faster and cleaner. A black hole works in a similar way. To spin that fast, matter probably had to feed it in a smooth and consistent direction for a long time. So scientists started realizing something important. Maybe black holes don't always need massive cosmic crashes to become extreme. Maybe some of them grow through a quieter, cleaner, more efficient process. That idea was already surprising. But then ID 830 made the mystery much bigger. Because ID 830 was not just extreme, it was growing too fast. When scientists studied its ancient light, they found a black hole that was bright in X-rays and strong in radio emission, signs that this object was very active. This was not a sleeping monster, it was feeding hard. And then came the number that made everything uncomfortable. ID 830 appeared to be eating at almost 13 times the expected limit. Not slightly above the line, not a small scientific adjustment. 13 times. That's like finding a truck on a road with a speed limit of 60, somehow doing 780. By our current understanding, ID 830 should have slowed itself down. Instead, it kept feeding, it kept glowing, and it kept throwing powerful energy into space. That combination is what made scientists look again. Because ID 830 was ancient, massive, active, and growing faster than the normal rules should allow. It looked like a black hole caught in the act. Not after the mystery, right in the middle of it. So now the question was no longer just, how fast can a black hole grow? The real question became, what was feeding it so efficiently? That's where the investigation became tricky, because astronomers cannot watch ID 830 like a video. They only receive its light, and different kinds of light reveal different parts of the black hole's behavior. Its X-rays suggested extremely energetic activity near the center. Its radio signal hinted at powerful jets. And together, these clues showed that ID 830 was not behaving like a normal feeding black hole. So scientists had to ask, maybe this black hole had entered a short, extreme growth phase, a moment where a huge supply of gas reached the center, the disk became overloaded, and the black hole started growing far faster than expected. But here's the interesting part. Even when a black hole feeds too fast, it does not always have to shut itself down completely. Some energy can escape through jets. Some material can be thrown outward. But if enough gas still keeps falling in, the black hole can continue growing. So ID 830 may have found a dangerous balance. It was releasing violent energy into space, but not enough to stop the feeding. And that could be the missing clue. Maybe the first giant black holes did not grow slowly for billions of years. Maybe they grew in short, aggressive bursts, gaining huge mass whenever the right amount of gas reached them. If that's true, ID 830 is not just a weird black hole. It may be a rare snapshot of the universe building a monster in fast forward. So what does all this really mean? It means the old picture of black hole growth was too simple. For a long time, we imagined giant black holes becoming monsters through huge cosmic accidents, galaxies crashing, gas getting thrown around, and the black hole getting a sudden feast. But ID 830 suggests something more interesting. A black hole may not always need a giant collision to grow fast. Sometimes its own galaxy may already have enough fuel. The gas just needs to reach the center in the right way. That changes the story completely. Instead of a black hole growing only because the universe throws a disaster at it, maybe some black holes grow because their galaxies quietly keep feeding them from inside. Almost like the galaxy is cooking at home using the ingredients it already has. And in the early universe, those ingredients were everywhere. Young galaxies were rich with gas, packed with raw material, and much more active than many galaxies today. So if a black hole found the right feeding path, it could grow much faster than we expected. This gives us a new picture of the relationship between a galaxy and its central black hole. They are not separate characters, they grow together. The galaxy shapes the black hole by feeding it, and the black hole shapes the galaxy by blasting energy back into it. That energy can heat gas, disturb star formation, launch jets, and change the future of the entire galaxy. So ID 830 is not just a black hole eating too fast. It may be showing us a phase where the galaxy and the black hole are locked in a very intense exchange. The galaxy feeds the monster fires energy back into the galaxy, and somehow, during that dangerous balance, the black hole keeps growing. That is the revelation. Maybe the first giant black holes did not need billions of years of slow growth. Maybe they grew through rare but powerful feeding episodes where huge amounts of gas reached them quickly, and the black hole found a way to keep eating without completely shutting itself down. In that case, ID 830 is not breaking physics. It is exposing a shortcut we did not fully understand. A faster, messier, more extreme way for the universe to build. So we started with a cosmic monster that seemed to be breaking the rules. But it turns out it was just showing us that we didn't know all the rules to begin with. The old, violent idea that you need a galaxy-on-galaxy smackdown to grow a big black hole is getting a major update. It seems they can grow up just fine on their own. Thanks to scientists like Dr. Becky Smethurst, this impossible black hole has peeled back a layer on the secret lives of galaxies, revealing a much cooler, quieter way the universe works. If you think the secret lives of black holes are as cool as we do us a favor and hit that subscribe button and ring the bell for more trips into the cosmic weird. And drop a comment below, what's another universe mystery you want us to tackle? Thanks for hanging out with us.